we've got to pick 6 different integers from 1 to 9, and such that the product is a square. So I'm going to write them out to start with, all 9. But I'm going to write them out as a product of their prime factors, because that's going to be a key thing here. Because when I multiply these numbers together, I'm going to have an even number of each one. So I'm going to have something like 5 times 2 all squared. There's obviously going to be some 3's in there as well. And in fact, this immediately rules out 5 and 7, because there's no way I can just times by 5 and get another factor of 5 in there somewhere to give me a 5 squared. And the same with 7. So they're gone very quickly, and we're just left with 7 options. And that kind of, that's good, because it says this can be done in 2 different ways. So let's take a look at this. Like I said, I need an even power. Well, I have to use 6 of them. Now let's look at all the powers of 2. I've got 2 to the 3, 2 to the 4, 2 to the 7. So I can't use all the 2's. So it's got to be one of these that I don't use. I'm definitely going to have to use the 3 and the 3 squared. But actually, if I use the 3 and the 3 squared, then that means that I've got to use that one as well. So that's got to be used. And actually, I need that 2 square. I can't use the um. I've now got an odd power of 2. So I can't use both of these odd powers of 2. So it's actually got to be these two. Okay, I hope I've made sense with what I've just said there. I have to use all the 3's to get my even power of 3. And then basically I have to use the 2 squared and then one of the odd powers of 2 to make it all work. So one option, and then the 1 doesn't really, 1 comes into it because I can use that one as well, but it's not as important as such. So one option is going to be 2 times 3 times 2 squared times 2 times 3 times 3 squared. So I'm ignoring the 2 to the 3 here. And that's going to give me 2 to the 4 times 3 to the 4, which is actually 2 times 3 to the 4, or 6 to the 4, or 6 squared to the 4. Sorry, 6 squared, which is 36 squared. And actually, that's one of my, that's either P or Q. So let's say P is 36. So I hope I've convinced you, like this is necessarily a square number, as you can see here as well. And then I can do exactly the same again, but I'm just going to replace the 2 by 2 to the 3. And so if I do that, I'm going to lower 1 from the power, but then add 3 to the power. It's going to be 2 to the 6 times 3 to the 4. Maybe like I can't write that as to the power of 4 as easily. Let's go straight for writing it as in squared form. So it's going to be 2 to the 3 times 3 squared squared. Okay, because when I expand this, I'll do 2 to the 3 to the power of 2, which gives me 2 to the 6, and this will give me 2 to the 4. Sorry, 3 to the 4. So then I'm going to get 8 times 9 squared, 72 squared. And therefore, Q is going to be 72, or vice versa. Doesn't really matter, because we're just asked for the value of P plus Q, so that's going to be 108. Now, I'm not, yeah, that's how I did it. Actually, now I've explained it that way, I'm thinking maybe that wasn't necessarily the best way. I think probably the best way of doing this question is, of course, yeah, you got to eliminate 5 and 7, and then maybe just multiply them all together. So in fact, that would be 2 to the 7 times 3 to the 4, and then realize, okay, yes, we've clearly got to use all the 3's. So they're in. And then we can see that, okay, I can only use, oh, I've got only used the 1, of course. Then I can't just use 2 to the 3 and the 2, because I'll be getting 2 to the 5. I've got to use that one. And then it's just a case of which one I don't use. So it's either going to give me 2 to the 6 times 3 to the 4, like I did it here, or if I don't use the 2 to the 3, it's going to give me 2 to the 4 times 3 to the 4, like I did here. So that's an alternative way of thinking about it. I suppose both are good. Anyway, what on?